agita numa só alegria, eternos Dodô e Osmar. Na Avenida 7, na Paz eu sou tiete, na Barra o farol a brilhar. Carnaval na Bahia, oitava maravilha, nunca irei te deixar, meu amor. Eu vou atrás do trio elétrico, vou dançar ao negro toque do agogô, curtindo minha baianidade na go. Eu queria que essa fantasia fosse eterna. Quem sabe um dia a paz vence a guerra e viver será só festejar. Laia, laia, já pintou verão, calor no coração, a festa vai começar. Carnaval na Bahia, oitava maravilha, nunca irei te deixar, meu amor. Eu vou atrás do trio elétrico, vou dançar ao negro toque do agogô, curtindo minha baianidade na go. Eu queria que...
Hi everyone. Sure, we missed the in-person meetings, right? Soon we will have them again, I'm sure. Welcome everyone for this roundtable. We'll be discussing some challenge in data science. I would like to join me for this roundtable, John Byler, Luciano Oliveira, and Pedro Silva. It is a great honor and pleasure to have them here with us to discuss this subject. I will start by introducing our guests, and then I will give the floor to each of them. They will give a short presentation, and then we will open the floor for discussion and for questions, okay? Any question that you might have, you can write in the chat, and we will put them on screen here. So John Byler is a University Distinguished Professor and Chair in the Department of Statistics at Miami University in Southwest Ohio. It's Miami, but when John explained me that Miami was not really the Miami that we are used to, so it is in Ohio. After ending his undergraduate degree from Miami University, he received a PhD in biostatistics from the University of North Carolina at Chapel Hill. You work as the National Institute of Health staff fellow before he returned to Miami in 1988 as a faculty member. He is the founding chair of the Department of Statistics at Miami and is currently in his 13th year in that role. Promoting quantitative literacy and enhancing connections between statistics and journalists are one of his most recent passions, in which result in the podcast Stats+Stories. If you search it online, Stats+Stories, you can find a lot of great conversations about statistics and about the sharing of information. He is currently finishing a book, Statistics Behind the Headlines, that is co-authored with a journalist, with a colleague of him. A perfect gift for someone you love, he says. He's most happy when hanging out with his kids. One is now in Chicago and another in London. walking his dog, reading fun fiction, and pre-pandemic, of course, and traveling internationally. That now it is not possible at this moment. John was the president of the International Statistical Institute between 2019 and 2021. Our second guest is Luciano Oliveira. Luciano obtained his PhD in electrical and computer engineering at the Institute of Systems and Robotics at the University of Coimbra. He did a master in mechatronics and a bachelor degree in computer science at the Federal University of Bahia. He is currently associate professor at the Department of Computer Sciences in the Institute of Computing and the head of the Intelligent Vision Research Lab. He is a specialist in the field of computer vision and machine learning and works mainly with robotics, smart cities, biometric systems, and biomedicine. And the third guest of today is Pedro Luís do Nascimento Silva. Pedro holds a PhD in social statistics from the University of Southampton. He is the Secretary of Science since 2019, a retired principal researcher from the National School of Statistical Sciences, the ENS, of the Brazilian Institute of Geography and Statistics, and was the president of the International Statistical Institute between 2015 and 2017. His main research interests include survey and sampling methodology applied to household and business surveys, as well as the analysis of survey data. So it is a variety of expertise that we have here. So I'm sure that this will be a very nice discussion. So I will now hand the floor to John. We'll do things in alphabetic order of the first name to avoid any kind of discussion. So I will hand out the word to John. You will share some slides in the beginning, and then we will move on.
Okay.
John, please, the floor is yours.
Thank you so much. Well, it is indeed a pleasure to be joining everyone. It's just a delight. I wish very much that I was in person there in Brazil. It's a place that I've loved to visit and would hope to do sometime soon once again. As part of this roundtable, we were asked to consider some of the challenges of data science. In terms of my remarks, I'm going to talk about three challenges: an issue of identity when we're thinking about statistics and data science, the knowledge base, staffing. That's kind of the challenge for finding out how do we meet the needs in society for the skill set. And then I'd like to take a few minutes and reflect on some of the issues of how academic degrees are evolving and think a little bit about statistics, identity, and degrees as a consequence of this. But before I continue, I'd like to thank Paulo for the very kind invitation to participate. It's indeed a pleasure and an honor. When I think about the identity of these three challenges, as I said, I'm going to explore this idea of identity and the statistics versus data science identity more in the sort of the second half of my remarks. But I'm going to start a little bit with kind of what is it people even look for in terms of jobs, a little bit about the knowledge that people have to have in terms of being able to function in data science and in statistics and analytics, and then also just a couple of comments about remarks, a couple of comments related to the staffing remarks. In preparation for this, one of the things that I did was I looked at the largest big city to where my university is located is Cincinnati, Ohio, in the U.S., in the Midwest. And on Indeed.com, a job site, I just did a quick search for how many postings did you see for statistician versus data scientist versus data analyst. And as you see, there's more than twice as many for data scientist than statistician, and about even more for data analyst. And there are some that would show up in common to these different job categories, but there were a fair number of unique components, and also the skills that were being required or requested in each of these differed somewhat. And now I did pick some of the skill sets here. I mean, one was, with the data analyst positions, they were talking about skills with software. A lot of them were SQL and, visualization tools with Tableau or Power BI, some analytics tools, as well as strong Excel skills. And they said pivot tables and VLOOKUPs. And these are actually cut and paste from the job ads that were there. In terms of the data scientist position, now this was a more advanced position, a data scientist 2 position, and you saw R, Python, SAS-related software general programming knowledge, including SQL, and then stat and machine learning techniques, at getting into these kind of supervised and unsupervised learning tools that many experience. But then ultimately some experience with data wrangling, quality, transforming, cleaning data, and so on. And interestingly, when I saw the data analyst position, I was intrigued to see that it just said all majors are welcome, although you should have some comfort level with working with numbers. And this also shows you some of the breadth that you're encountering in terms of the types of jobs that people are applying for that have quantitative skills. Now, this also then says, well, what do we do in terms of the knowledge base for this? And the example that I think about that really resonates for me is a model for teacher training. And by teacher, I'm thinking like the primary, secondary school teachers. They talk about pre-service training. Before you enter the teaching workforce, what skills, pedagogical and content knowledge do you need before entering? And then once you've done that, there is this almost lifetime of continuing in-service training after you've entered the workplace. I think that's the reality now, and maybe it's always been the reality for us, but we need to think a lot about the idea of the pressure to enhance our skills with new data, new tools, and software. Staffing. I think the reality is we don't have the pool to meet the demand in business, industry, government, and academia. And we have to think about how are we going to address this? And I think it's going to require multiple strategies. Some is we need to increase the flow of students into the data science and statistics majors. But we also need to think about the people that are currently working professionals and what skills they need. And we need to be able to also enhance some of the data science skills of current faculty, because we're not necessarily going to be able to hire in, we're going to have to also grow these skills. I'm going to change gears a little bit and now talk a bit about kind of one way to think about evolution of degrees. And this is something that can be done at any institution, at any university. And I'm going to talk in 3 parts about going from our math origins to a statistics identity, the connection to computer science and data science, and then thinking about analytics as a separate component. I'm going to use local experience as kind of a surrogate here for general trends. So I'm going to state my assumptions. I'm also going to say that just recognize we do see that data science and analytics demand outpaces the supply. So we have to address this. In terms of in the United States, the undergraduate degrees in statistics and biostatistics has just exploded. I mean, you're looking at this growth that's appears to be exponential in recent years, just about. And in the past, if you took a time machine back into the 1980s, you might say that a master's degree was considered the degree to work as a statistician. It's not clear that that's the case now, and actually, I think it's clear that it's not. Even in our previous math and stat degrees, we would see lots of mathematics courses ranging from 3 semesters of calculus, differential equations, then abstract algebra, analysis, and more. With stat including some possibly applied stat, then probability and some, the mathematical stat sequence, and then more in this experimental design and regression. And sometimes you'd even get a computer course thrown in as required, but a lot of it was just based on templates of analysis. Then all of a sudden, in the very much in like 2010s and plus or minus, and there started to be a lot of growth. There were initially degrees in the U.S. in statistics, and I recognize that the experience in Brazil and around the world may differ some, but I'm using this as a case study to describe what could happen and what was observed. And what you'll see is that we still had the extensive, lead in terms of the mathematical prerequisites, but now all of a sudden you're starting to get more hours, and we now have a stat programming class, and our majors are growing. The math and stat degree is there. The BS and stat is exploding. But now what's changing? Well, what's changing is as we see that our jobs are really, viewed as incredibly attractive. Statisticians get, highly rated as a STEM job, science, technology, engineering, math, business job. Data science is showing up in a lot of lists as top. So are our stat degrees keeping up? And one of the things that we started to do locally is thinking about a data science as well as statistics track. And now all of a sudden in data science, we're thinking about object-oriented programming and data abstraction and database systems and managing big data. And also then data visualization and stat learning is starting to show up in our degrees. Some issues is that we still have we had a very significant math prerequisite, and you don't need to be an engineer to drive a car. Can we think about analytics without necessarily having this very challenging price of admission to do this? And so are there partnerships that we could consider? And could a new major be associated with it? And the answer is yes, at least, or well, if not, then I'd be turning it over to my colleagues on this roundtable panel today. We can think about data science and analytics as being separate. And, this particular reference that I have is that the idea that there's even analytics translators to talk about what we've done. You need to have more than domain knowledge. You need to be able to take this structure problem solving and use tools to address it. So, you don't necessarily have to be able to master all the techniques or be able to be researching the techniques to be able to applying and using them. I'll just mention here that we recently started a Bachelor of Arts in Data Analytics, where we have a core course which includes professional communication, and the engineering department contributed that. Math foundations for analytics, and that's something math has contributed in my university. The programming and scripting class is something my department does, as well as the building, managing, and exploring data sets and analytics. And we're teaching those two classes this year for the first time. We also have stat modeling and data ethics as part of this. The foundations course is kind of the greatest hits in mathematics for data analytics. And this includes ideas from set theory. When you're thinking about what you're doing with managing data with joins, you're thinking about set relations and how things come together. So you have to have some sense of that, as well as the logic and building functions. So this is really just thinking about the mathematical tools that might be relevant to someone who's thinking about programming and implementing solutions. We also have concentrations ranging from partnerships with geography, biology, sports, and social data, which includes political science and gerontology. There could be a future to this, but that's still to evolve. We're starting to see things grow, and we're thinking about this as a partnership across multiple departments. And I think that is going to ultimately be a real strength of this. And I'll mention this is even distinct from business analytics, which is in the School of Business, not my college. We're seeing growth, and the table here is that, you'll see the Bachelor of Arts in Data Analytics, the top left, has gone from 0 to a bunch. Data Science and Statistics has grown, but the BS in Statistics has shrunk accordingly, not surprisingly. So we're seeing this kind of continuing growth, but we're seeing growth in an area where we didn't have growth, and that is that Bachelor of Arts in Data Analytics. So there's we've gone from nothing in 2019 to 85 students now, and with the thought that possibly we could have hundreds a year entering in this system. I want to close with this image here of a shark, and there's a quote from Annie Hall, which is a movie from many years ago, which is, relationships are like sharks. They have to keep moving forward or they die. And I think what we have on our hands is a dead shark. Now that is a comment related to a relationship, but I think that we have to think about that in terms of our degrees, our what are we doing in our curriculum, what we're offering for those of us that are in academia. But I also think that when we look at statistics and we look at our role and our context with work with colleagues in data science, this is something that we will also need to keep moving forward as we consider our career in the changing world where we have data science as a major consideration. My contact information is here with email. There's the Twitter handle. Thanks again, Paulo, for the shout out to the Stats and Stories podcast. And again, friends, it's so good to join you. I wish it could only be in person, but it's a pleasure to be here and also to share this time with colleagues from around the world. Thank you.
Thank you very much, Sean, for this great warm-up. It will be a good discussion. Just to remind everyone, tomorrow we will have a second roundtable which will deal specifically with education in data science and statistics. So I think John's talk is a kind of warm up for 2 days and tomorrow's roundtable. Thank you, John. I will now end the word to Luciano. Luciano is going to talk a little bit about this topic. Please, Luciano, the floor is yours. Let me share your slides. Yes, please go ahead.
Thank you very much. Thank you very much, and I'm going to start to apologize myself if my internet is stable or broken. So I'm sorry, but sometimes I experience some instability in my internet. So hi everyone, I hope you're all okay and safe. Thank you very much, Paulo, for the invitation. It's a pleasure to share with everybody this topic. So I'm Luciano, as Paulo said. I'm a head of iVision Lab, so I researching in the computer vision field. I'm the computer science guy in this roundtable. So it will be a pleasure to share some of my knowledge in this topic. I will try to talk briefly about some challenges in data science before our roundtable. So instead of starting by defining data science, which probably was already defined 1,000 times here in this conference, I will begin with some meta questions about data science. So the first questions are there deep questions in data science, as there are some questions in each field that form the requirements for data science. So in computer science, we can see some very important and very deep questions in statistics too, in mathematics too. So we can see these kind of questions specifically for data science, or it borrows from the requirement fields like computer science and statistics. So does data science inherit its deep question from its constituent discipline, or does it have its own unique questions? So the second question is data science about methods or the use of those methods in a domain context? We can think about methods that is conceived only in the field of data science, so these methods are conceived in statistics, in mathematics, or in computer science. Can one study data science without studying the domain context which the data comes from? When should a set of methods be considered data science and not just methods in computer science, statistics, and mathematics? So I think there are no definitive answers for these questions, but probably they will help us to understand a little bit more about the talents of data science. So I think data science is in just the beginning, and we have a lot of to experience in the road of this exciting research field. Let me alternate this, so just to check if my slides is coming up. So there are many ways to present the challenges, and I like it so much the way that John presented here. I think I thought a little bit different, because data science itself is not my main development tools. So I'm, as I said, I'm a computer vision guy. So I think in methods to solve problems in the image domain. So I thought that if I categorize the many challenges that we can face in the data science, it should be easy. So I try here to categorize the challenges in order to put things more clear. So I don't think this taxonomy would be found in any other place, since it was conceived by me for my brief talk here before the roundtable. So the first category is the challenge that lies on the research field. And you're going to talk about academy and the challenges in academy and research in data science. and so it corresponds to the subjects related to the research part of data science. The second category is about the talents is concerning specifically to the process of development and the applications themselves that they are developed. And the third category, and the last one, tries to bring some challenges related to human principles or ethics that a data science should be concerning when developing an application for a data science problem, or even the challenges on security that to guarantee that the data will be safe during all the time they will be manipulated or processed. This later issue is particularly important since data science is all about that. Concerning research field, I listed some challenges here, and the first one is understanding how fragile models are to perturbations, especially deep learning based models. I research in deep learning based. In deep learning based models, we conceive deep learning architectures. So we can say that if you are interested to conceive a method that are able to deal with in the wild data, instead of all these data that you have very canonical and very normatized, and surely we have to deal with perturbations and noise, so that it's of underlying importance to tackle these issues in our conceived models, and it's especially noteworthy when you talk about deep learning models. So deep learning model have to be conceived with the thought that you're gonna experience noise and perturbations, and data will not only very canonical and very behave. So the second in the list is how robustly characterize or measure the uncertainty of the method. So when you're thinking to measure the uncertainty, for example, in deep learning, the majority of the application relies on the softmax function in the top of the model, but this function overestimated the uncertainty of this prediction so that errors can be made with a high uncertainty. Recently, we proposed a new framework based on Monte Carlo dropout to provide the uncertain information in the deep learning model in charge of classify histology image, which tackled some issues of softmax providing promised results. However, although we are excited with the results, much has to be done for us to have a more reliable uncertainty estimation. Another challenge in the list of research field is at what point does more data and more compute not help? This is something very important to be done, but unfortunately very complex issues. So it's not there is no definitive answer for this question. Data preparation is another very important challenge. So you have to gathering noise and to deal with the noise and incomplete data, multiple heterogeneous data sources, and all the preparation of data is time-consuming, costly, in fact, very costly, and it requires multiple expertise that certainly takes a lot of time, either in a scientific project or in a company-driven project. So concerning the development and applications, we have a lack of professionals that John exposed very well, and these professionals need sound knowledge and subject depth to understand not only data science techniques but also the domain field. One thing that is very clear is that data science is not about using methods to process data, but more importantly, is about knowing the domain of the data. So it's crucial that professionals or researchers have a very solid knowledge about the domain or application. Problem identification. Before starting working, have a clear understanding of the requirements. Understand the requirements is not a simple stuff, since data by itself brings the domain knowledge, and most of the time we don't know what we want to do about the data. Cleansing of the data. get rid of inconsistency and anomalies. Make a cleansing of the data so important then to know how to process the data. Communication, domain knowledge. The domain knowledge, again, to reinforce its importance. So domain knowledge is probably one of the most important things that a professional should be aware when working in a data science field. Communication of the results. Either to the academy or to companies, communication of the results is very important. Is a very important and probably one of the most difficult things for some professionals or some researchers. What is concerning ethical and trustworthy? We have ethics, and ethics should be pervasively discussed in all these axes: data, algorithms, and practice. The fair data principle. So fair means findability, accessibility, interoperability, and reusability. FAIR principle was proposed by a committee of scientists in order to aid the community to deal with data. So it's very important to be aware when you are dealing with data in data science. So these principles are very important to stick in our mind. Bias in algorithms. Much has been discussed about bias in algorithms, so that the professionals should be aware of social, gender, and racial aspects of the algorithms in order to deal with bias and to be aware on how the algorithm influences in the community. And the last one is the privacy. So privacy is one of the most important aspects of data science, and methods should guarantee it should be seen very carefully. So deal with some aspects of computer science like blockchain and cryptography. Cryptography and encrypted data is something that a professional should be aware. Some remarks here is that it's worth reflecting on data science as a field, which obviously share commonality with computer science, statistics, and mathematics. Probably in the future, we can think in data science as a discipline with very solid and surrounding knowledge that is not borrowed by, it's borrowed from other disciplines or other fields. And what will data science be in the near and far future? Probably the answer is in the hands of research and education, and we have to think about how to educate our students and how educate our researchers in our labs to think about all these aspects that were discussed here. So thanks very much, and I'm finished.
Thank you very much, Luciano. Thank you. It is those are indeed great topics that we'll continue discussing after Pedro's talk. Thank you. I will now pass the word to Pedro. Pedro, thank you very much again. If you don't mind sharing your screen, your slides.
Will do. There you are.
Yes, so, there they are. Please go ahead, Pedro. Thank you very much again for your availability.
Thank you very much, Paulo, for the invitation and for the opportunity to be here, part of this discussion. I was educated as a statistician, but when I look at the scenario for what is being described as data science, I can honestly say that I am a data scientist. I have been doing stuff in this domain from the very beginning because of the jobs I had in the past. It's great to have to speak after John and Luciano, who also raised some of the concerns I have. But I'll start from, let's say, perhaps a more basic level than they have. So I will talk about some challenges, but I'll first talk a little bit about data science. These are two words that were combined to define this field, data and science, and I'll spend a couple of minutes just talking about each of the components of this field. Let's start with data. I think we live in something we could easily describe as the data era. It doesn't matter whether the data is big or small for any particular topic, but we certainly live in an era with unprecedented availability and access to data. We are both, as individuals, producers and avid consumers of data. And this graph gives you an idea of the huge amount of data which is being produced and stored and made available somehow every year. An estimate from around 2006 suggests that we produce something in excess of 1 exabyte of data every year. He estimated that 1 exabyte would be about 2/3 of the annual production of information around 2016. And given the previous trend of growth in this field, it's certainly much bigger right now. And this graph is illustrating the volumes we are talking about, okay? Data are now accessible in digital form for many topics. They are cheaper to collect and store in many, but not necessarily all areas. They are available from many news sources, or we have learned to explore or think about these news sources. They are of an increasing variety of types: messages, transactions, images, sensor records, etc., you name it. They are occurring in large volumes and in real time. And I would say data are now ubiquitous. They are everywhere. They are around us. We produce them and we use them. We consume them all the time. A lot of these data from these new sources are not coming or becoming available in traditional ways. They are named organic or found data, which is a way to describe that were not planned or designed to answer specific research questions or questions we might have. They emerge out of the processes carried out by organizations, individuals, and so on. They are often incomplete or subject to unknown selection and selection bias. They may be subject to measurement errors. And when taken at face value, they are not necessarily always fit to help answer the questions we have. And Luciano has already raised issues on this problem when he mentions the need to cleanse, to work with the data before we can do analysis and some other learning from the data. Now let's turn to the word science, which is part of the name. I'll use a simple definition, which is from Wikipedia. Science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe, about the world, about the things we see, okay? Okay, science itself has been evolving from a beginning where it was mostly empirical, where people were learning and trying to describe the natural phenomena. It evolved into creating theories that helped us to produce models and generalizations about the world around us that helped us accelerate the process of learning about the world and the universe. In the last couple of decades, two new trends emerged. First, a computational branch, where we started to become able to use computers to simulate, to increase the speed with which we tested our theories and checked or verified success or failure of hypotheses generated on these theories. And more recently, the data or e-science moment when we have data captured by instruments or generated by simulators, processed by sophisticated algorithms embedded in software. And even the knowledge generated by several of these processes is no longer stored just in other formats, but stored in computers that you now have to access before you get access to the knowledge. And scientists are the people analyzing these vast databases, files, etc., using the tools of computer science and statistics. I will use this graph to describe what I consider is a simple representation of our traditional scientific learning process. It started with some theory or questions or hypotheses that were formulated to engage with a problem. Then we would plan and obtain some data to help us answer these questions that were formulated beforehand. Once we get the data, we do exploration, we check, we verify, we cleanse, etc., the data, and we go for formal analysis where we establish some results that we then have to communicate to those who are asking the questions, and we cycle, because every time we learn something, we either destroy or improve the knowledge we had before, and we keep going with this process. This is very much in line with this diagram, which is from a consortium that developed framework for teaching and learning about the data science. And they describe data science as the science of learning from data. And the cycle you see here is exactly what I used in the previous slides. There are more elaborate versions of this graph in the document of this consortium, and it draws the attention that data science draws on several disciplines, including computer science, mathematics, and statistics, together with areas such as problem elicitation and formulation, collaboration, and communication skills. This is all fine, but sometimes we come across projects or instances in this data science and the data era where the learning process seems to have changed a little bit. In many instances, there are data out there. People start looking at the data and formulating questions after they have seen the data, and they then explore what the data can tell them about these potential questions. And they go through the cycle of exploring, analyzing, and communicating results. But this is fundamentally different from the traditional learning process cycle, because now you are asking questions after you have seen the data. And this has some provokes some challenges for us, because if we are, for example, able to use computer power to ask many questions about signals in a bunch of data, eventually we will find signal when perhaps there was no signal anticipated in that sort of scenario. Sometimes noise can be confounded with signal in some instances. I'll bring a graph that I saw just the other day from Marco Putz, a methodologist at the CBS in the Netherlands, where basically he's suggesting that all the knowledge we gain through data science, to be considered good science, good knowledge, it has to endure the test of science. Remember, I said from the definition I presented, science produces knowledge that has to withstand the tests. In some instances, we see projects from data science where people start through the data, use all the exploratory and analytics tools they have to detect patterns, and then formulate hypotheses, and then formulate theory. That's all fine, wonderful, but to be good science, the idea is that now you have a theory, you can put your hypothesis to the test by designing and obtaining data that can show whether your theory is good. And if you have good science, good knowledge, solid knowledge, after you go through the deductive process as well, then you should go ahead and doing the interpretation of the knowledge you gain through this data analysis. And I'll use this probably old example many of you will know about to illustrate this issue. What you do not see in a data set or in a set of data sets still may harm you. This example is quoted in the literature attributed to Abraham Wald, who was asked as part of a team to investigate where engineers should put more protective armor in aircraft they were sending to fight in World War II to reduce aircraft loss. And what they had as data to work on this problem was a series of annotations of the points where aircraft which returned to base were hit, but were still able to return to base. And this illustrative graph sort of shows the kind of problem we had. There are many concentration areas with lots of shots in the aircraft which came back. The problem is that analysts only saw the data from the returning aircraft, nothing from the lost ones. And that's where selection issues come into play. And they can be very severe in some of the data analysis that people can do with a lot of these modern data sets. I'll give some comments on a paper, an incredibly important paper by Xiao Meng in 2018, in this apparent paradox with the big data world. Imagine a scenario where you have an administrative register covering a fraction of a population, say C, where M is the number in your register and N is the total size of the population. And if you only have access to the register, you only see the M records in your register. An alternative approach to do inference, to learn something about this population would be to use sampling. And let's imagine the simplest kind, simple random sampling, where you sample from the full population, a sample of size n, having thus a fraction f of your population to observe. And typically, we are discussing here scenarios where we imagine the sampling fraction will be much smaller than the size of the full register you might have access to. The question he asked was, how large should your sample be so that the sample-based estimator would dominate the register-only estimator in terms of mean squared error? And the answer is given in this table I calculated with the theory in the paper for a population near the size of the Brazilian population. And the exercises in the paper focused on the American population, which is a bit bigger. But basically, if you had a population of 200 million individuals, and you had a register covering only half of this population, say 100 million, and you had a situation in which you want to estimate the mean of a target variable y, and the indicator of whether the individual is in the record or not is correlated somewhat with the y, the target variable, even modest correlations of 5%, say, a sample of about 400 selected through simple random sampling would grant you inference, which is as good or better than having access to the whole 100 million records. This is an apparent paradox, but the theory is solid behind these figures, and you should believe them. Selection is a severe issue in the big data world, and we should be very concerned with these sorts of issues. The result from this theory is very clear. Blind faith in the registry, in the big data source, can be dangerous and lead to results of worse quality than those made possible by small, well-designed samples. And the trend that is emerging in this area is that lots of the good people don't have the blind faith. They are now trying to find the best ways to combine the fantastic volume of information available from the big data sources with additional information that can help mitigate or eliminate the bias coming from selection. Lesson one here is having more data does not mean having better data. New data sources, such as this one, have emerged such that we can learn a lot from them, but the knowledge we gain should be tested with the same rigor regarding quality and reliability as that originating from traditional sources, like surveys, censuses, and others. And the challenges, to be honest, may be bigger with big data sources, because unlike with a small, well-designed sample, we may not have enough time to check the quality of the individual data we get with the same level of care that we should do with much larger data sets that we will probably have to rely on quicker and more automated approaches to do just that. The area where I worked most of my professional life, official statistics, and I could extend these ideas to public statistics as well, has developed a range of frameworks to deal with quality issues, including accuracy, where bias and variance are the key components, but also relevance, accessibility, clarity, coherence, comparability. All of these quality dimensions are important for data science projects, even in the cases when the data and the knowledge to be produced will not be made public, will be made available to the people who funded it, such an enterprise or a body that is not willing to publish the findings of some of these exercises. So I'll finish with these two words that I think were already mentioned by Luciano and partly also by John. Ethics is at the heart of the issues we have to face, and quality frameworks that need to be developed and used to support data science engagements that produce valid knowledge. In the ethics, I won't go into detail, but I would just say can do is not the same as should do. And we have seen in the literature and the news recently a number of instances where people have done things that they can do, but they should not have done, probably. So summing up, data science is here to stay. We must engage to benefit from emerging opportunities for all these topics like research, education, applications, and jobs, and to help meet the many challenges posed by this data era and the emerging scientific paradigms of the e-science or data-centric discovery. Thank you, folks. I'll be ready for your questions next when Paulo brings them to the floor.
Pedro, thank you very much. I will now bring John and Luciano, and now we'll have the chance to have some general discussion based on what you shared with us and on some questions that might arise from the audience. So I think to start, I will give the chance to all of you to comment on what you listened from the others. If you have some comments on what others say, so it will be a good kickoff for this. Please, John, go ahead.
I want to thank my colleagues here. So Luciano and Pedro, I very much appreciated your remarks. I always learn a lot when I get to have an opportunity to be on a discussion like this. But Luciano, my question I'd like to pose initially to you is how do we implement the kind of breadth of ideas like that you were describing and that Pedro was describing in academia or in other contexts where you often have these units operating independently. So, you have computer science, and at my university, computer science is in a different college. It's not even in my college; it's a different one. So, how do we build kind of the collaboration that data science requires with some of the existing structure that's in place?
It's very good questions and very difficult to. I think concerning my ideas of research, I can share my experience in my lab, that is iVision Lab. So iVision Lab was thought and it was conceived to be a space, democratic space that we can share ideas. And it's not a kind of space that you have a professor very, very distant from the students, but a professor that is immersed in the same problems as the students do. So I had my research projects, share ideas with my students, so that I give them the opportunity to share their ideas, and I learned a lot. I learned a lot because sometimes you don't have time to study with depth all the subjects that you are researching. So I think it's very important things that you have a time to share the ideas and to talk to your students. And we have some discussion groups about politics, about ethics, and about philosophies. So we discuss philosophy, we discuss some situations in the world that is far apart from the specific research field, but sometimes it has a huge impact in the life of the students when they are researching. So we discuss ethics, we discuss politics, we discuss very technical issues and very details about all the things that you are doing with the students, and we are always open to to give and to receive advices from them.
Can I say a word on that topic?
Sure,
I
of
had
course.
the fortune of being hired to work at IBG very early on after I graduated from my first degree, the BSc in statistics. I learned very early on that the kinds of problems I had to work on required collaboration from people from different knowledge bases. IBG has to produce statistics on a vast range of topics. Every project I was involved, we had economists, sociologists, geographers, the people from the computer branch, us, the statisticians, the methodologists, the people who were doing the analysis, the people who were doing the logistics for fieldwork, administration. Very challenging projects, and sometimes big ones. One of the first jobs I had was to work on developing a new survey, a producer price index that was non-existent. Oh, what a challenge. I had to learn to interact with all these people. Even language was a problem. We had names for things that were different between us and the economists and the computer scientists. I think data science shares the same sort of baseline issue. You have to engage multiple knowledge to do good projects in this field. You have to have the domain knowledge, as Luciano correctly strengthened in his presentation, but I don't see any single individual having the ability to master all the knowledge in data science that is needed for a project, for a good-sized project, let's say. So we will need collaboration, folks. And John has clearly made the point very clearly in his talk. And the knowledge of how to do good collaboration also needs to be developed. There are organizations which are better at doing this than others, and we have to, learn from the best and move forward.
Yes, indeed.
Completely.
Please, Luciano.
I agree completely with Pedro, and I think the domain knowledge is a very important aspect of a professional. But I agree that one professional is not able to master all the domain knowledge. I'm researching in medicine, specifically in digital pathology, and we have a very often meeting every Monday, and you are discussing with the computer scientist guys and also with the pathology, and this has been this for 3 or 4 years, and today when you are starting to researching in a new topic in this field, we are always have to to talk to the medicine guys and to discuss, because it's very complex, and even if you are researching a specific topic, even that it's harder to find a consensus, and it's very difficult.
Yes, I will start to share some of the message that we received on YouTube. Damian Grams, he said that in Brazil and maybe also in Latin America, we haven't seen much of an increase in the number of statistics undergrads. And this comment was when John was talking. So indeed, I also don't see that in Brazil. It's, maybe that will happen at some point. I'm not fully sure.
I have a reply, a comment on
yes,
that.
Yes, please.
The most of the degrees in statistics are sponsored by public universities, mostly federal or state funded. Very little in the private sector. Maybe that will change. Private sector is now responsible for offering about 90% of the university or tertiary education in Brazil. The public sector is pretty small in overall terms. In terms of quality, it still retains some of the best that is available, but in terms of volume of students enrolling and graduating, it's the minority now. And unfortunately, I don't know why, our private sector has not yet picked on this opportunity, amazing opportunity to develop degrees with more modern flavor than the traditional universities can. But we have started to see emergence of postgraduate after university, like in Bahia, you have done something. In São Paulo, there are a couple of initiatives. There are popping up masters or diploma degrees that cover this topic, which I don't see as bad. It's a good idea. But our undergraduate degree level, in fact, is lagging behind. I think opportunities will be spotted even by the private sector to move things forward in the coming years.
Yes, thank you, Pedro. I will share some slides of acknowledgement. Denise, she will be with us tomorrow in the second roundtable. She thanks for the presentations. Also, Nadiana Bazi, she says that, the presentation is very rich and detailed. Also, our colleague here, Lilia, also thanks the presentations. And I have here some specific comment from, I don't know the name, it just has the username. The question is, I'd like your opinion about the current information of misuse of the data obtained with the biggest platforms and decision driving, notably Facebook and Google.
So if I could just jump, I think this touches something that I think that you heard from all three presenters, which is the critical aspect of ethics training in people that are involved in data science work. I mean, there's issues of privacy and confidentiality that's long been well appreciated in official statistics. There's certainly a lot of respect for medical records. I think that within the context of data science, it's almost too easy to get a lot of information, and there has to be built-in safeguards. And part of that is the issue that Luciano mentioned, that has to be a conversation, but it has to be something that is a thread that will go through all of the education and training, and it has to be something that is foundational and fundamental. And I think if it's not, then I think we'll continue to see these kinds of concerns about misuse of data. There clearly has been an appreciation for kind of algorithmic bias and certain predictors that should or should not be involved in decisions that are being made. That's the appreciation for that has definitely grown. But examples such as the concerns about how information is being used on platforms really calls us all to embrace the idea of ethics as part of how we train and how we operate as data scientists and statisticians and computer scientists.
Thanks, John. If I can comment, the topic I raised toward the end of my presentation is can do should not be interpreted as should do. I'll give an example. Facial recognition. We now can do it. And it's pretty clear that there are instances where we should do it. Like if you're controlling entrance to a secure data facility that holds data which the privacy of which must be very well protected, maybe facial recognition is part of the tools you are agreeable to use to grant access only to those who need to have access and have been cleared to have that access. But facial recognition on other contexts is clearly unacceptable. And this is part of the discussion that should be part of all the projects. Examples of situations where can do is not should not be meaning or understood to be should do. We should have the discussion. And ethics is about, rights, and not the rights of single individuals, but the rights of the collectivity as well. We see that discussion in other contexts like vaccines and many others. It should become part of the regular discussion for projects which involve, big data sources to which individuals contribute, sometimes without explicit consent and so on. So there are very, very good points that this is part of the discussion and the engagement we need to have.
Yes, please, Luciano.
Taking the last point that Pedro raised, I think that the discussion of ethics is not a matter of enrolling to a discipline and discuss some topics that you can see, or it's good or it's bad. Sometimes when you talk, for example, face recognition, it's very important for us to have a very good security system provided by the state. But this all this system comes with other issues that involves problems with ethics, problems with the state politics. And sometimes you have to discuss, and as John said, it's profound, and you have to think it over in its foundation. The foundation is the foundation of a society that you have to think on how to educate people on early age until the university. And when people comes to the university and enter in a course that is pure technical course, you have to think that it's not only the techniques, but also all the discussion about the philosophy, all the discussion about the life, on all the way you thinking about things in the life.
Yes, thank you. I will share some other comments. I have here a comment from Lion. Lion is a former student of us. He says that for me, data science has 4 legs: statistics, mathematics, computing, and business. There is no way to do data science without multiple concepts.
So can I'd just like to jump in, and I
Sure.
might say that the 4th leg may be flexible. Because there are people that are working in political campaigns that are social scientists. So it could be and social science, or there are people that are looking at the genome and doing bioinformatics work. So the 4th leg may be biology. There are people that are working in geospatial. So that the 4th leg may be geography. I think that for this, part of it is contextual. So yes, I very much agree that there is sort of technical foundational skills as mentioned here, but I think that it's really important to have a context and having some deeper some meaningfully relevant knowledge of the area in which these tools are applied. And I think Luciano suggested that, as did Pedro.
Yes. One more comment.
Maybe you can change.
Please.
Maybe you can change the fourth leg. Maybe you can change the fourth leg to the domain knowledge instead of business.
Mm-hmm. Yeah. The next comment is from Isabel. Isabel, she says, thanks for raising some important issues and challenges. Certainly, this is the era of big data, but also the era of misinformation and conspiracy theories. Difficult to debunk.
There's a really neat project that was done by some psychologists, Sander van der Linden, and mm-hmm. It is a they put together a fake news. It was called the Bad News website, where you would have a game that would help to try to use ideas of kind of inoculation theory, where kind of like with the same way that you get a vaccine inoculation. And in this game that Sander van der Linden and colleagues built, you would basically act as someone who's trying to promote a conspiracy theory. And by being exposed to the strategies that this is used to manipulate attitude and attention, then you are kind of developing kind of that resistance. I posted it, Paulo, to the site there, and if you want to share it with others, I think you might enjoy it. By the way, thanks again to Paulo for the shout out to the Stats+Stories podcast. We had Sander on, and he'll talk about this idea of inoculation in an episode later this month.
Thank you, thanks, Sean. There is now a question by Vinod. Is asking why there are not global coordinating efforts to make statistics a more loved and accepted discipline among the scientific community. I think Pedro and John can say a lot about that, because they were leading for a couple of years the International Statistical Institute, which is probably the largest association of statistics in terms of diversity around the globe. Please.
I have two words to say. There are organizations devoted just to do that, and there is a massive initiative at the United Nations level, okay? They have this program of the Sustainable Development Goals with targets and metrics associated with this, which had the agreement of all the countries, member countries of the UN, and they promote this very strongly, including with educational initiatives. Statistics is at the top, my friend, Vinod. We have never been in such evidence as before now, and I think the trend has not stopped. We are still growing. But of course, this is a big challenge. The world is much bigger than statistics, data science, and so on. We have to engage. Just yesterday, there was a posting on a Brazilian major newspaper of an American scientist, Bonner, I think Joe Bonner, maybe I made a mistake on her name, who is advocating that data science should be taught even from preschool. These are skills which people need to learn in this modern world. So teaching kids how to learn requires them to learn a little bit about data, a little bit about building and learning from data in very simple context, but even from the very younger age. I'll find the link here to share with you in a moment.
So can I jump in too, please? This is
yes, of course.
Yeah. So 2/3 of this panel love statistics. So, and maybe the other third likes it too. But so I think that what happened, the world is much different now than if you look 30 years ago about attitudes towards statistics and attitudes towards data. And when I look at the world of statistics now, statistics was often taught as a series of recipes to bake a hypothesis test. Now what's changing is that people are talking about thinking with data. What's exciting about statistics is not the algebraic mechanics to calculate the number. What's excited is designing a study that will help, that will represent a population and lead to valid decisions, informed, relevant decisions. I'm very optimistic about the trajectory of statistics and data science. I think that statistics is enhanced by these discussions of data science, as is our partnership with computer science. I think that thinking with data, getting away from saying it's just these algebraic manipulations, but it's in fact computing with real problems and dealing with this in meaningful ways that will generate the interest and excitement about this. So I'm an optimistic guy about this path.
Maybe I was giving the word to Luciano because maybe since he's not a statistician, maybe he can also help us how to get statistics more loved among the scientific community. Please, Luciano. That's a very, very difficult question for you.
What I have to say is that I would say that 100% love statistics because I love statistics.
and computer science to us too.
Of course. I have here a question for John about your book. The question is whether in your new book the misinformation issue is addressed there.
It's not as that's a great question. What the book is, it's going to basically say, what are the statistical and journalistic concepts do you need to understand when you read the news, when you read headlines and news? So it's deconstructing the news to think about concepts and principles. In terms of the kind of the issue of misinformation, I would refer you to work by people like Gerd Gigerenzer, who wrote a book called Risk Savvy. I will post this in. And David Spiegelhalter is someone who is that there is a group called the Winton Center for Risk and Evidence Communication, and those are organizations that are very good about kind of thinking about framing the kind of argument for this. I think that I would also that like the bad news site that I had mentioned previously, where you have cognitive psychologists like Sander van der Linden, and their work is pretty much directly related to this. So there are psychologists that are working on inoculation theory. Ultimately, one thing that I've become convinced about over time is that people often don't change their opinions because of data. I think they change. They'll change opinions because of story, because of there's something that resonates with you in your heart. So when there are discussions about people who disagree about whether they should do this or not, the argument is not probably doesn't convince you because of the infectivity rates, but it may convince you if you think that you're protecting your parents from getting sick. I think so part of it is it's not just it's not a data story, it's not a computation story, it's an emotional component and a psychology story. And in the same sense that we've been talking about collaborations here as it benefits data science, and I think we have to think about our collaborations with people that study how are biases baked into what we do, and how do we change those? We're talking about attitude change, and that's outside the scope of my expertise. Sorry for the long-winded answer, but
no, thank you. Please, Pedro.
A quick comment. I think data only become relevant when they help us to tell a good story about what we learn. And that I learned from you, my friend.
By the way, if I were going to recommend a book to people, there's a really nice book by a journalist called News and Numbers by Cohn. The News and Numbers book is really Well, it doesn't really deal with the issue of misinformation, but it deals with the idea of what should you be ready to answer about science to a journalist, or about statistical analysis to a journalist, when you think about the kind of work that you do. So that is a resource I would suggest.
Yeah, thank you. I have here one question. I think this should be less so that we don't have this session too long. The question is a bit tricky, and it depends on the point of view. Is by Netanya Nabazi, and the question is: who should be considered first when applying for a data scientist job? A statistician, a computer scientist, or a mathematician? Anyone does anyone dare to comment on that?
I think it's statisticians, stat, with the knowledge of mathematics and computer science.
I was going to say possibly none.
No, we're wrong.
Because it depends on what they know. I mean, there may be a statistician that is completely unqualified for such a position. There may be a computer scientist completely unqualified. There may be a mathematician completely unqualified. If I were going to bet, I would say stat and computer science might be where I would start in terms of a ranking. But ultimately, for me, I would say, don't look at the job title, look at the skills required. What are the skills the positions require, and which candidates would come forward with those? Because you may find that any of those three might completely satisfy or not come close to satisfying what the job would require.
Yes, I saw a definition for data scientists that I sometimes use in my talks, which says that a data scientist is a statistical minded person which has knowledge on computing, programming, and mathematics, and who is curious. So I think this is a quite nice definition. Of course, it is difficult to master those things, but at least some knowledge on programming is essential. Some knowledge on mathematics and statistics as well. So, if I believe that if it is only one of these fields, it will have some difficulties to do most of the jobs. So yes, indeed. And I think we don't have more questions in the chat now, so I'm leaving the last question to Pedro. Pedro said he wanted to have a question for John, I think specifically. So Pedro, please.
John, it regards your comment about growing the knowledge in our current staff, academic institutions. What can you share with us in terms of initiatives your university or people you know are doing in this regard? Because I see this as a huge challenge for us to grow this field. We have to start with the education, and the education of the people who are already there educating others. So,
it's always fun to point out the problems. It's often hard to point out the solutions. So what I would suggest that, no one will be done learning. If you're in a technical field, you will not be done learning when your degree is granted. Your degree is ultimately your ticket to admission to a lifelong pursuit of learning. I look back. So the R language 2 years ago celebrated its 25th birthday, its 25th anniversary. It didn't exist when I started my practice, when I finished my degree, but it's something that I now use routinely. Now that's a tool, but tools evolve. The challenge here, Pedro, is that we need all organizations need to find ways to carve out time for existing staff to increase their skill. And that increase in skill could be the time for Pedro to learn Python. It could be the time, for, while Luciano and all of his students are using GitHub repos routinely, it may be something that the stat students are just starting to. We have to find ways to say, we need to connect to the people that are hiring our graduates and say, what skills do you need for these students? And then we need to find ways to maybe have our current staff learn it, because we can't just hire people that will address all this. And then having said that, we also need ways, the people that are working in official statistics, Pedro, and whether it's in your organization or it's, CBS in the Netherlands or NIOSH, if you look in the U.S. government agencies, they still have to learn these skills too. So I think that we need to call upon our professional societies to provide training. So Luciano, I'd love to attend the Hadoop course, Hadoop for beginners, that a computer scientist might put together. And maybe that you would like to see what sort of a statistician is thinking about visualization. I think we need to be thinking about challenging our professional societies to provide ongoing professional development and growth, where our academic units, our business, industry, and government operations are supporting people to continue the growth of their skills. So those are some of the things that come to mind. And one thing you saw, Pedro, when I mentioned the degrees that we're starting, we have the people that are teaching ethics are ethicists from around the university. The people that are teaching technical communications are people from the English department. The people that are developing this kind of survey of mathematics for analytics were mathematicians. So we've worked with our computer science friends for some of the object-oriented programming and other skills for the students. So I think part of it is we need to think outside of our units to find some of the skills, but we also need to build within our units those skills. So thanks for the question.
Thank you very much, John. We are running out of time, so if someone has further questions, if you look in the conference website, you have a book of abstracts, and the emails of Luciano, Pedro, and John are there. So if you have any questions, please feel free to write them. So I would like, just if you would like to say any final words for this roundtable, any final thought. Otherwise, I will proceed to the closing.
I'll say 2 words. Challenges are opportunities.
Those are 3 words.
Sorry. I'm a bad statistician. I don't know how to count.
He said 2 plus or minus 3. So it was okay.
Sorry, Pedro.
You have a standard deviation there.
I agree with Pedro. I mean, I think this is exciting. I can't imagine a more exciting time to be practicing our field. It's exploding, and there are opportunities. I love the idea that I get opportunities to collaborate closely with colleagues in computer science and with disciplinary specialists around social science, biological science, business opportunities. So I think it's exciting. I think it's a great time.
Right.
I'm very happy after participating in this roundtable. I think it was a pleasure to me. Share my time with very sympathetic people and with very pleasurable subjects and discussions, and I learned a lot from you.
And me too.
Many thanks.
Me too. And Paulo, thank you so much. Muito obrigado.
Good, you are almost ready to come with your knowledge in Portuguese.
I may be exhausted.
So thank you very much. Thanks, John, Pedro, Luciano. Thank you for sharing your knowledge, your thoughts on this topic. I hope that everyone enjoyed as much as myself. And thank you again for your availability. So thank you very much.
It's a pleasure. Thank you.